Good morning all. So today we are going to cover the topic is the Phasor algebra. So in that Phasor algebra we are going to see how to add the two phasors, how to subtract the phasors and how to multiply the phasors and how to divide the phasors. Those kind of concept we are going to see, and after that we are also going to see a small concept which is called admittance term. We will going to define that admittance term in terms of this AC quantities. So as we know that we already studied this Phasor algebra, this vector algebra in our +2 standards, but however we will try to rewind this concept here. So you know that any vector can be represented in different forms. If you take that any vector here, so vectors can be represented in different forms, different forms here. So what are different forms here is, if you talk, the first one is called the rectangular form. The second one is called the triangular form, trigonometric form. The third one is the polar form. So these are the different forms we have to represent any vector or any phasor quantities have the different form. The fourth one is called the exponential form. So these are the different forms we have to represent any kind of network into these different ways. So as we know, when you talk about the vector, so how will you represent a vector? If you let us consider the xy axis we have. So let us consider I have the x-axis and y-axis. You have the x-axis here and you have that y-axis here. So if you talk this xy axis into a real axis, or you can sometimes you can also call it is imaginary axis. So you can call it is a complex system. Xy is representation also in complex representation if it is a real part and it is a real part and it is a imaginary part. So those concept also we will see here. So if you take any vector, any vector, so then how will you represent that vector into in a xy system or xy this graphical system here. So let us consider, so this is my vector A. My vector A1 has a magnitude of A1. Let us consider my vector A1 has a magnitude of A1, where this vector A1 is making an angle with respect to x-axis. With respect to, I am assuming my x-axis as a reference part or reference axis. So with respect to this reference axis, my A1 vector is making some angle with respect to that reference axis. Let us consider pi 1. So that pi 1 is a angle which is making that A1 vector with respect to the x-axis. As already we know that always our vectors rotates in a anti-clockwise direction, isn't it? Anti-clockwise direction. So my vector is rotating in this direction. Like this, my vector is rotating in anti-clockwise direction. So with respect to this direction, so this is what my marking of the pi angle with respect to x-axis. So where, if you take this vector here, where my A1 is a magnitude, A1 you can call a magnitude of the vector, and which is displacing with respect to x-axis in counterclockwise direction. So A1 is a vector magnitude, you can say this is A1 is a magnitude, and this vector representing or displacing with respect to x-axis in counterclockwise direction. In counterclockwise direction. So that is the meaning what I explained to you. So from this point I can say, if I can say also, my a1 vector leads x-axis by x-axis, that is reference axis, by a pi 1 angle, isn't it? So my a1 vector leading x-axis by some pi 1 is the phase angle between that leading concept. If you going to talk here, suppose if I want to represent this vector, this a1 vector into a rectangular form, then what could be the formation of this rectangular form? As we know that you are familiar with this concept, but anyhow I am recalling or I am rewinding this concept for you to understand the vector forms here, algebras. So if you want what is meant by the rectangular form, so you can come back here, so your vector, this a1 vector, can be decomposed into different components here. Your a1 vector can be has the two different components. It can be decomposed like this. So this is the along the x-axis component. So this component I can write it is a, and along the y-axis this component is I can write b. So my a1 vector can be decomposed along the x-axis and along the y-axis. So a is the decomposed of the a1 vector which is going inside along with the x-axis. B is the vector which is going along with the y-axis. Then what could be the value of this one? a1 I can write here because I know this magnitude, a1 I know, and this phase angle I know. So use these two and use the trigonometrical formula so that you are getting this one, a1 cos pi 1. So that is the value for a. Similarly, if you want to write for this b, so this b is also equal to this b, isn't it? This is the same. So this is the same. So I can write like this also. So the b is equal to, I can write this one, this b is also I can write, it is a1 and sine pi 1 or sine pi 1. So I am writing sine pi 1. So this is the magnitude, the decomposition of this vector magnitude I can write here. So if you come back here, what is meant by the rectangular form is also called a Cartesian form or standard form. If any vector, if it is there, so let us consider this is my vector I am taking, this is the vector, then this a1 vector can be represented into Cartesian form is nothing but a plus some jb plus jb, where jb it means that it is a real part and imaginary part, isn't it? So why it is j means this is the plus j imaginary axis, and this is called a minus j, so which is going along the y axis. So you can represent if you want, then your real part plus your imaginary part is going to be a complete vector. So it is composed of these two terminology. So a plus jb. Suppose if my vector, sometimes my vector, suppose if it is like this minus j and this is the real axis, then if it is my a1 vector and it is some pi angle, if it is something like this there, then how will you define this one? I can want to rectangular form, a1 can be a minus jb, because it is going downward direction, so you can getting the minus point here, so downward direction. So like that you can define the vector. If any angle or any rotation point, you can define the vector diagram here. So not an issue for this. And this is the a1 is equal to a plus jb. And if you want, you can also, what is a here? A is nothing but what? You can know what is a1 cos pi 1 plus this is j and a1 sin pi. So this is also you can called a rectangular form. So how will you find the magnitude of this vector? How will you find the magnitude of this vector? If you want to find the magnitude of this vector, I can find under root square of a square plus b square. So I am simply applying that the vector algebras which you have already studied in your +2 standard. So that is the concept I am trying to recall here. And if you want to find what is the face angle here. So face angle also know how to find this one. So tan inverse of B by A, isn't it? So you go here, you go back and you see this is the triangle you have. In this triangle apply, then you will get this formulas, isn't it? So this is what you are going to get. So these are the different forms. Rectangular form is nothing but standard form is this one, isn't it? A plus some JB or X plus JY. So that is called a rectangular form. Now come for the polar form here. Come for the polar form here. So we'll see what is this polar form here. So polar form, obviously it is the vector can be defined as, this vector can be represented in polar form, its magnitude with an angle, with an angle pi 1. So that is the polar form, it is called it magnitude. Any vector, the vector can be represented, any vector can be represented to its magnitude with a angle. So that is what the polar form you need to understand here. So what is this for a A1 vector? If you want to represent this A1 vector into magnitude and A1 and B1, so what is this magnitude? You know magnitude is what? This is, you know, this is what the magnitude, A square plus B square. And what is this angle here? So angle you are going to get this one, right? So it is the angle of tan inverse B by A. You can write something like this. This is called A, or you can write it is the A1 with the angle of pi 1. So this is called a vectorial magnitude form, isn't it? This is what you can need to understand here. So this is one of the polar form. Now we'll go to see what is the trigonometrical form. So trigonometrical form also, you know, you are very familiar with that. So once again I will recall this one, trigonometric form. Trigonometric form is nothing but, suppose if you have a vector, some vector is there, then this vector can be has some A1, that is the magnitude, and with a cos pi 1 plus j sin pi 1. So this is how they will you can represent a trigonometrical form. A1 cos pi 1 plus j sin pi. So these are the different forms, and I will clarify this different form. You can convert your trigonometric form into rectangular form, rectangular to trigonometric, and polar to rectangular, rectangular to polar form. So different ways you can convert them to understand this one. So I will take the examples here, and I will explain you, so that it is very easy for you, isn't it? So that is what I need to recall some concept here. Okay, we'll take one example and we try to do that one. Suppose this is the vector is there. Vector has the 5 plus j 12. This is the vector system we have. This vector system, then they are asking to convert this into trigonometric form, and the polar form, because whatever the given is in Cartesian form or in rectangular form, they are asking to convert this into a trigonometric form and polar form. We will see this how to convert, because you already seen the different formulas. So by using the different formulas also you can do. So I will represent this v is equal to 5 plus j12 in a this diagram here in x-axis and y-axis concept. So this is my imaginary part. I can take, it is plus 12, isn't it? So this is a 12, it imaginary part, and this is my phi somewhere, assume this is pi. So where the exactly my vector is coming, that is nothing but v. Is vector is coming, that is nothing but e. I can write here. So it has taking some angle with respect to this one. I can take, this is the pi. So I don't know what is pi here, so I can go for this one, right? So how will you, if you want what is the magnitude of this one, how will you write the magnitude? You know how to write pi square plus 12 square. So this magnitude will going to get 13. How will you find what is the face angle here? So face angle, you know, this is the opposite by this adjacent if you do this one. So you will get tan inverse of this one, tan inverse of this 12 by 5, so you will get 67.38 degrees, 38 degrees. So this is we are getting. Now what is my question is, I want to convert this into this polar form. What is the polar form? So you know what is meant by this polar form here. The polar form is nothing but this magnitude with a angle, isn't it? So I can write this is the 13 with an angle 67.38 degrees. So it is converted into polar form. Similarly, if you want to convert into trigonometric form, those trigonometric form could be like this, isn't it? Where A1 is magnitude. So this A1 is nothing but magnitude, that is 13. I can write this is 13 into cos pi 1 is nothing but what? 67.37, 67.38 plus j sine, again what is pi 1? 67.38. This is called a trigonometric form. Trigonometric form. So this is how you can convert your polar form into different forms. Now we'll see what is the how to add, how to subtract, and addition and subtraction. Some kind of things we're going to see here. How to do this this for your Phasor Phasor diagrams, and addition and subtraction. So you know for have already you have seen. Okay, last form also there, right? That is, what is that last one? The last form you can say this is the exponential form. So you can say exponential form is nothing but it is some exponential of some j into some theta. So this is the kind of thing has been written. Some magnitude a1 is magnitude e exponential of j into some pi 1. So if you write in terms of, then this is called the exponential form. Anyhow, you can go through this one so that you will get some detailed explanation of this one. A1 e power j pi 1, if you write, this is called a exponential form. Okay, fine. We'll go for this concept is called addition and subtraction of the Phasors here. So you take one note here. Note you need to understand here. For addition of subtraction, for addition and subtraction, the Phasor, you need to use the Phasor in rectangular form. So rectangular form, rectangular form, Phasor are best suited. Phasor are best suited for addition and subtraction. For any addition and subtraction of any 2 vector or 3 vector, always go with the rectangular form. You convert anything, if it is there, you convert into rectangular form, then you add or you can subtract. That is a very easy to do that one. Otherwise, if you have the polar form and asking to add, that is a little complex as compared to. So for addition of subtraction of that any vectors, please try to prefer to go for the rectangular form. Prefer to go with the rectangular form is the best way to understand. So I will show here. I will show. Suppose I have the two networks like this. 2 vectors if I have. So this is the one vector which is going in this direction. I can take this is the v1. This is another vector is going in some v2 there. Assume. So with respect to this is nothing but my a1. This is a1, and with respect to this is b1. I can take this is b1. With respect to this, I can take this is the a2, and this one I can take this one. So this is I can take is minus some b2 because it is going downwards to that imaginary axis. So and I can also take this is the pi 1, and if it is like this, then this is the pi 2. I can take these are the angle making with respect to your x-axis as a this is a reference axis we are going to take. Then how will you define this v1 vector here? So that is I will write the rectangular form here. So it is simply a plus j b1, isn't it? If you want to write what is this one into polar form, then this is v1 into some pi 1, isn't it? This is what we are writing. Similarly, if you write for what is the v2 here, so this is a1 b1, so this is a2 minus JB2, because it is going downward direction, you have a minus point here, so that is what you are writing, and V2 is nothing but this is minus pi 2. So this is what. So what do you understand by what you are understanding by this concept here is my V1 is leading with respect to x axis. So that's why this is the plus pi 1 we are getting. So I can say by seeing this one plus pi 1, I can say it is leading, my voltage V1 is leading x axis with a pi angle. If we are getting the minus pi 2, it means what? It means what? So my vector direction is going like this in anticlockwise direction. So with respect to x axis, if you compare my V2, so it is lagging with some angle. So that is the pi 2 is the lagging angle of my V2 with respect to x axis. So I can say it is a lagging, isn't it? So if you any kind of things, if you find with the angle of plus and minus, then you can able to understand is the leading quantity or lagging quantity. That is what the concept you need to understand here. Then how will you add this vector? Then you can say V1 plus V2, both I can add here, isn't it? So do this one, then I can write very simple a plus JB B1 plus A2 minus JB2 like this. Then I can separate the real parts at one part, and I will also separate the imaginary part at a one point. So B1 minus B2, isn't it? It is very simple to calculate. Similarly, if you want to find the subtraction between these two, also you can do. So if you want, you can do the subtraction addition. If you able to have a rectangular form, then it is very convenient to do the subtraction and addition. So that is the point I want to highlight here. So if you have any addition and subtraction, please try to prefer the rectangular form of the any vector, so that it is very easy to do the operation. Now come to that second one is called the multiplication and division and the division. So here what I suggest you there, you take one note here. If you want to do the multiplication or division of any vector, any two vectors or more than two vectors, so for this go with polar form, because it is best suited to do the solution very easily. It is best suited. So that is what I want to talk here. So I will show this one, how to do this one, and it will be very easy. Suppose you have the vector this one a1 plus jb1 is there. So if it is a vector is given, you have to convert this vector into a polar form. You know how to convert. This is the magnitude, and this is the angle. So this is the pi 1. We are converting into this one. Suppose I have a vector, this one second vector, then this is this is the Cartesian rectangular form you have. You can convert this into a you can say polar form. So this is what the polar form you are going to get, minus pi 2, isn't it? So if I ask you to do the multiplication of these two, if you do the multiplication of vector v1 and v2 multiplication here, then v1 is pi 1 multiplied by v2 with an angle of minus pi 2 is there. Then what you are going to do here is, this is nothing but you can take this v1 and v2 multiplication, but when it comes to this angle, it is the summation of the both angle or addition of the both angles. So I can write, you have to add the both angles here. So this is what you need to do here, addition of the two angles. So these two magnitude will be multiplied, but whatever the face angle should be adding, or you can say addition of or summation of the two angle. So this is what the way you have to follow to do the your vector multiplications you can do. Then what is the concept of division? How will you do the division here? v1 by v2, if you want to do this one, So as we know, this is polar form needed. So this is my polar form pi 1, and this is another polar form needed. This is the pi 2. Pi 1 and pi 2 is there. So this is also I can write, this is my magnitude V1 by V2, where my angle should be, subtracted here. So I can write this one should be subtracted with the another angle, subtraction here. So this is how we are going to write the angles here. So V1 by V2, and this is pi 1 plus pi 2. So this is how you are going to try to do the division of the two vectors, where this V1 by V2, if it have a magnitude, then you can do this kind of things very easily, isn't it? This is a magnitude, and this is the angle of between these two. So here we are taking the subtraction between the two angles. So this is the subtraction between the two angles, where in multiplication you are going to take the summation of the two angles. So that is important. You forget about this sign, because sometimes may be minus or plus, sometimes it may be minus or plus, but this is the very important sign you need to understand. For multiplication it is plus, and for division it is the minus. We need to write and how to do the required things. So let me to take one numerical, and I will do this operation so that you can have how easy to do this kind of things, you can come to know. So I will take, suppose, add, subtract, multiply the following vectors. We do this, multiply, add and subtract of the following. Two vectors is given to 3 plus j4 is given, and we also have the 2 plus j3 also is there. 2 plus j3 is given. So I can name this one solution. If you do, I will name, this is the x vector. X vector is 3 plus j4 is there. So this is in rectangular form. I can also convert this rectangular form into this one. I can convert into a polar form as well, isn't it? So how will you convert this one? You know. So I can convert this into a polar form. So I need the magnitude. So magnitude is nothing but 5. I can write, because under root of 3 square plus 4 square, that is going to give this one. And angle is in a tan inverse of 4 by 3. Tan inverse of 4 by 3. If you do this one, so you're going to get angle is 53.13 angle. So this is what my 3 square plus 4 square magnitude, and tan inverse of 4 by 3. So this is what I am doing to convert into polar form. Similarly, do this rectangular convert into the polar form here. Again this is coming, if you do this one, so this is 0.605, and this is coming 56.31 degrees. So this is what you can say 2 square plus 3 square with an angle of tan inverse of 3 by 2. So this is you are going to get. So this is my rectangular forms. We have, and these are my polar forms. Now we have the two vectors x and y. I have a polar form and a rectangular form I have. So I can do the addition of this one. To do that addition of this one, I have to use the rectangular form. So rectangular form is 3 plus j4 plus 2 plus j3. I need to use this one. So I will get 5 plus j7. Now see how very simple it is by using the rectangular form for addition. You can do the subtraction also. Same. So you use the rectangular form to do the subtraction, so that you will easily get this point, isn't it? So this is nothing but, again do this one, then you are going to get 1 plus 1 plus j1, something like that you are going to get. So this is the how. This is the first point, and this is the second one. Now go for the third one. I have to do the multiplication, isn't it? Multiplication of the two vectors. So for the multiplication and division, I will go with the polar form. So what is the polar form? The x vector. So this is what I have, 33.13 multiplied by 3.605 with 56.31 degrees, something like this. So 5, this if you do these two multiplication, then you will getting this 18.025 with the summation of the two vector, this pi1 plus pi2, something like this, isn't it? If you do this one, then you are going to get 10.44 degrees. This is the very easy to do this one, isn't it? So if suppose if you have that division point, division also it is very easy, because you have to do 53.15 by 3.605 angle 56.310. So how will you do? This is 5 by 31605, and this is angle. How to subtract the angle from pi1 minus pi2. So 53.115 degrees minus 56.31 degrees. If you do this one, then you will get 1.387 with angle of minus 3.18 degrees. So this is what the division. So like this you can do the n number of questions, and you can able to solve. So these are the fundamentals we are going. So we'll go, and the last concept in this session is called the admittance. Admittance. What is this admittance is called? It is denoted with Y, capital Y, and it is measured in mho. Measured in mho, the units. So what is the definition is? It is a reciprocal of the impedance. It is the reciprocal of the impedance. Reciprocal of the impedance. Impedance capital Z, isn't it? So you can write like something like this. Y is nothing but it is 1 by Z, or you can write Z is equal to it is 1 by Y. It is a reciprocal of that kind of things you need to understand here. That is called a admittance, or it is a mho. Suppose I have a network, simple network here. It is like a pure resistive network, AC, purely resistive network is there. Then you know the current I and voltage is there. So here, what is my impedance? My impedance of this network is simply the resistor. You know, you are very familiar with this resistor. And if you want to find what is this admittance here, admittance is nothing but 1 by Z, isn't it? So what is this one here? Z is nothing but 1 by R. What is meant by this 1 by R? 1 by R is nothing but I can write it is a conductance. It is a conductance. 1 by R is nothing but a conductance, isn't it? 1 by R is nothing but a conductance. The reciprocal of resistance is conductance, isn't it? That can be also measures in mho. Measures in mho. So that is the relation you need to understand. Suppose I have a network something like a inductor. You have a network inductor, then V and I is there, and you know the inductor has the reactance part, and that reactance also I can write XL, isn't it? So you have already gone through this concept. So the reactance is called XL is the reactance of the inductor. So this is nothing but also it is nothing but a impedance, isn't it? This is also a kind of impedance. So Z is equal to XL I can write. If you want what is the admittance for this one, again do this kind of things. So 1 by XL, or 1 by XL is also denoted with B. It is called B, and this is called a susceptance. Susceptance. And the unit per susceptance is Siemen. Unit for susceptance is Siemen. It means the reactance is reciprocal of susceptance. So that is the point I want to talk here. A resistance, a reciprocal is conductance. Reactance, reciprocal is susceptance. So that is the need. Similarly, if you go with that what you call this capacitor also same. So you know capacitor also is reactance has Xc, isn't it? So here whatever the resistance part of the capacitor, that is called a reactance, and the reactance is called Xc. Xc is the capacitor reactance. This is also I can write into equal to this impedance here. then it is a capacitive reactance Xc. If you want what is Y, again write 1 by Xc. This is also nothing but a 1 by Xc is nothing but 1 by this reactance, isn't it? 1 by this reactance is nothing but susceptance. This is nothing but susceptance. So reactance, capacitive reactance or inductive reactance. Reactance is the term common. So we can call it is a susceptance also. So this is the susceptance. You can say B, and units are you can measure in that Siemens, isn't it? So that is what I want to talk here, and I want to show here. So till now you might be gone through that Z is nothing but under root of some R square plus XL square, isn't it? So this kind of concept you might be studied, or Z is equal to under root of R square plus X square, or sometimes you might be studied that from the previous lectures, the impedance is equal to, if you take RLC series circuit, then R square plus XL minus XC square. It means my inductor is dominant, then this could be the equation. So these are the impedances only, isn't it? These are the impedances only. This kind of concept you have already studied in simple RL, RC and RLC circuit. So this is the impedances of the this kind of things. But here my impedance, this impedance also I can write into Z is equal to R plus JXL. Can I write like this? R plus JXL. So this is also going to be my impedance. Similarly, I can go with that XC also as well. So similarly, if you want to talk here, what could be the relations here? Then you come to know that. So here my Z is equal to R minus JXC. R minus JXC you are going to get. So why you are getting this minus XC and why you are getting this plus XC is, if you want to represent these two impedances in a complex axis, then the complex system, then you come to know that you are easy to understand this one. So this is my real axis, isn't it? This is called a real axis, and this is my imaginary axis. Imaginary axis are plus J, and this is called a minus J axis, imaginary axis. Okay. If you take the impedance diagram for RL circuit, if you take the impedance diagram for RL circuit, try to recall that. So that is nothing but this R, this is nothing but your XL, and this is nothing but your Z, isn't it? So this is what your impedance diagram for RL circuit. So this is the Z. So obviously, what is this JL is nothing but this is the imaginary part. So JXL I can write. So what is my this part is nothing but R plus JXL. R plus JXL. So this is real part plus imaginary part we are going to combining in the combination. So this is the RL circuit. If you want to tell what is the impedance, Z is equal to R plus JXL. Otherwise, Z is equal to under root square of R square plus XL square. So this is how you are try to correlating all these relations with respect to this diagram. So you know this concept, because how to do the impedance triangle, that is already we have gone through that. So this is how you are going to getting the concept here. Then how will you justify this one? Why you are getting this negative part here? Yeah, as you know, if you try to recall the impedance triangle which have drawn for your RC network, then this is the diagram we have drawn for your RC network, isn't it? Like this, the impedance triangle is going to come. So it is the real part, this is the imaginary part, and this is the minus imaginary part. So this is the point up to this one is R, and from here to here it is coming XC, and this is called Z. So some angle is there, pi, assume pi is some angle is there. Then instead of representing this vector here, so this is going in a negative part of the imaginary part. So I can write this is a minus JXC. It is a minus JXC. So that's why if you want to write what is Z here, Z is nothing but R minus JXC. You are trying to writing. So this is the impedance of your RC network, impedance of RC network. So this is what the admittance concept and impedance, how they can be represented in this way. So based on this concept, I will draw one diagram. So you just try to remember this one. So it is very easy for you to understand the part here. So if you have a real part, you can say real axis, and it is a imaginary axis. So it is a plus j, and this is your minus j imaginary axis. If you have, this is minus real axis, if something like this, you assume this one. Then where could be my inductor part and where could be my capacitor lying, I can able to see. Along the real axis, positive real axis, I can show my resistor. So this is what my resistor is I'm showing here, and possibly my inductor is in this, maybe in position in positive imaginary axis. So this is my XL, you can say, or j omega L, I can write XL or j omega L. This is what I am trying to write here. Or you can say this is JXL, isn't it? So JXL, and this is my capacitor where it is lies, something like. So my XC I can write minus J by omega C. So these relations how you are coming, you also know. So from this you can try to write any kind of equation into this one. So I hope you have understood this concept, and I will stop this lecture for today's session. Thank you.